Hi, and welcome back to the next module, which is going to be an introduction to Kubernetes in containers. So to understand what vSphere with Tanzu is doing is it's going to give us an infrastructure of Kubernetes to be able to run containers. So in order to effectively manage this solution, you're going to need to be able to have a foundational understanding of two key pieces here. One, what are containers? And two, what is the basic architecture of Kubernetes? So these two constructs inside here are what we're going to cover briefly in this module. It's going to be broken apart into two lessons. Our first lesson, we're going to take a look at the basics of containers. Then we're going to do a series of labs, actually 3 of them. When we come back from our labs, we're going to dig into a little bit more inside Kubernetes so you understand these two. These are what I'm going to say the foundations that we're going to be building our infrastructure on top of, and it's important for you to have a basic understanding of what are containers and what is Kubernetes. So let's go ahead and get started. An introduction to containers. Now, a nice thing that is important that is for us is that we really don't need to have a super in-depth knowledge of containers. We actually need a very minimal, at the very top level of knowledge of what comprises a container. This is where your developers are going to be needing to know everything about the containers. We, on the other hand, we're just able to run their containers on top of our Kubernetes infrastructure. So the degree of knowledge that we need to know about containers, what we're going to cover inside this lesson, would be probably adequate for you to move forward with your rollout of Kubernetes and vSphere with Tanzu. So let's go ahead and get started. What we want to do inside here is we want to compare for you, because that's going to be the easiest thing for us. You already know what a virtual machine is. Why don't we simply just contrast what containers look like versus virtual machine? Where are their similarities and what are their differences? So that's what we're going to do. Secondly, we're going to identify the parts of a container system. Okay, any container runtime environment is going to have different parts, and we're going to explore those a little bit. Again, your knowledge of this is going to stay really at the surface. We're not going to go super deep inside of it. I would encourage you to, if you want to dig further inside of it, you're more than welcome to, but you'll typically find you don't need to have a really depth knowledge about containers. And then we need to understand here the basic Docker workflow that your developers are going through repetitively as they're developing their application. Because the workflow that they're using is where we're going to intersect with them. So they're going to produce a container image, and we're going to need a repository for them to put their container image in. And that's where our two worlds basically intersect. So let's go ahead and get started. We've got on the left-hand side over here what a virtual machine looks like. And on the right-hand side, we have what a container looks like. Now, you'll notice the first 3 layers down here are identical. Both of them are typically going to be running, well, they're going to have to run on a server somewhere. That's where they're getting CPU and RAM. Something's got to be controlling that hardware, so we move up and we say a hypervisor. And then on top of that, 3rd layer here, we're going to have some type of virtual machine guest OS. Now, as you know, this doesn't have to be a hypervisor. We could be bare metal, but we've already been down that road, right? I mean, we know that the bare metal has its set of cons that most of us are going to lean more towards using a virtual machine. And by the way, 90-something% of the containerized workloads are running on top of a virtual machine. So really, it's from here above that we have our differences. When we are building virtual machines, we're building the virtual machine typically to run an application. Our users are coming to us and they're saying, hey, I need a timesheet application, or I need a vacation request application that we bought. We need you to help us get it installed and deployed and running. So we take a look at the specs and we go, okay, they need this operating system. So we whoosh, spin up a new virtual machine, and then we take a look at the installation instructions and they go, oh, you got to install .NET, or you got to install a Java runtime, etc. So we start deploying the dependencies that the application requires, and then ultimately we put the app on top. Most of us are shy about putting two applications on one VM. Why? Because we've ran across conflicts of the dependencies between app 1 and app 2. Maybe you're running a Java runtime of, some version x.y. App 2 does an upgrade and they need x.y plus 1, and now the other app doesn't work anymore. Been there, bought the t-shirt. We know what that's about. Compare that now to containers over on the right-hand side. Inside here, you'll notice our app 2 is built inside this purple box that has app 2 dependencies inside of container B. Same thing's true over here with container A. It's in its own box. That's going to be my container image. So in the image are the dependencies, and app 1 here can't see app 2's dependencies. And app 2 can't see app 1's dependencies, which, hallelujah, we now don't have this dependency a conflict that would typically occur. Now, in order to be able to run containers, you're going to need some type of container engine to be able to run the containers. So far, this should give you a brief explanation of the organization or the packaging of a container. Another way to look at it is we can look at it inside this table. On the left-hand side over here, we've got our VM. What is the VM actually doing? Is it's encapsulating an entire operating system and anything that we've installed inside that operating system. So the dependencies and the application, and it's all inside that virtual machine. That virtual machine in turn is going to be scheduled by the hypervisor, which means we're running on top of that hypervisor. And typically booting a virtual machine, depending on your operating system, it's going to probably take minutes, seconds. It depends on your OS, but typically most of us are used to, a 2 to 3 minute style boot time for our OS to boot and our application to be somewhat functioning before it's ready to go. Compare that to the right-hand side now of containers. What is the container actually encapsulating? It's encapsulating the application and the dependent binaries or libraries that it needs. And we're going to explore a little bit more in a few slides how that's occurring when we get there, when we're talking about a build file that are the instructions to do that. That container then is going to be scheduled by the container host OS. That's what's actually scheduling it to run. It's actually calling the container runtime engine, which in turn then is running the actual container. So the container is being run on the container host OS, which that is now equivalent to my virtual machine on the other side. And it's going to be running in most cases on some type of hypervisor. Again, it could run bare metal, but 90% of them are running on a virtual machine for all the benefits that that provides. The neat thing about this is starting up another container, because typically this is already booted and ready to go, is going to be taking typically seconds. So if I go back to this picture inside here, as I want to start up more containers, I could drop another container C here on top of this VM, and its boot time is going to be within seconds for it to be able to get the image to be pulled and to be instantiated and ready to go. So you're starting to be able to see some of the differences. So that container host OS can be built several different ways. A very popular way to build that container host OS, or the VM that I'm going to run my containers on, is using Ubuntu with the Docker Container Runtime platform installed on top of it. This is a very commonly used deployment. First of all, it's all free. Okay, you're going to find lots of references, blog posting, YouTube videos, etc., using that specific platform. Now, it's not the only one. I could obviously substitute Ubuntu out with multiple different operating systems, and we now can even run Windows and run containers on top of it. So your operating system is really up to your choice. However, you want to consider that there are OSs specifically developed for running containers. So they got a much more trimmed down operating system, less of an attack footprint to come after. One that we're very familiar with is Photon. CoreOS is one, and there's others that are out there that you could search. It's up to you to kind of choose which one, and we're going to talk about which ones that we're going to be using in our solution coming up. Where do we run this at? That OS could be installed on a physical machine, bare metal. This is really more about the 5% here. As a virtual machine, that's typically the 95%. That's where the majority of your workloads are going to be getting run at. So we've been going at this for about 12 minutes now. Why don't we go ahead, let's take a short break, go ahead and get some coffee, stretch your legs, and let's come back and we'll pick up and talk about the container workflow example that you're going to need to understand. All righty, I'll see you soon.